Lesson 3. The Aircraft and its Environment.
Here we will focus on the airplane, how it flies, and the environment it operates in. Becoming more familiar with these subjects will help answer questions and ease concerns which might come up during a flight.
Dear Captain Chance, taking your course helped me so much. All 4 of my flights went very well. I'd never had turbulence before on flights but did on these, and I was able to stay calm. Takeoffs still make me nervous, but I was able to remember that planes are built to fly and do their job well. I have another set of flights in a week, but I'm much less nervous now.
The plane is a plane. For years, the airline industry has tried different methods for dealing with people's fear of flying. They've attempted to make the inside of a plane feel like a restaurant, bar, or movie theater. They design jet bridges to not only shelter passengers from the weather, but also disguise the reality of actually boarding a plane. Maybe one of the reasons people get nervous flying is that restaurants and movie theaters aren't supposed to tilt, change speed, and bounce around a little bit. Well, I've got news for you. That entertainment center is first and foremost a flying machine, and a magnificent flying machine at that. Commercial jetliners are wonderfully designed, state-of-the-art aircraft. They are meant to fly, and they fly superbly. Commercial airline pilots go to great lengths to make your flight as smooth and motionless as possible. But you should know that these planes can really perform if needed. They have big, powerful engines, sturdy, efficient wings, and very responsive controls. Technically, these jets are not certified to be aerobatic, but they can really maneuver. We could probably even do loops and rolls, but I promise we won't. The fun stuff is usually reserved for the Blue Angels. So please don't be in denial about the plane. It is primarily designed as a flying machine. You should feel very safe on it. All right, are you feeling a little nervous right now? Well, let's take a moment and use deep breathing to calm down. You push your stomach outward and slowly inhale through your nose. Fill your lungs from the bottom up, then pause. Then slowly exhale. Feel free to hit the pause button any time to practice your deep breathing. Your airplane is not going to fall apart. The FAA mandates that modern jet aircraft are designed and built with large safety margins. All aircraft and their equipment are built from FAA-approved designs and manufactured under FAA-approved systems. Coming out of the factory, the planes are thoroughly flight tested before certification by the FAA. Structurally, these aircraft can withstand many times the stresses and forces which can be imposed upon them in flight. The wing of an aircraft is of course very strong. The wing is commonly built as one continuous unit extending through the fuselage. It is constructed with huge reinforced spars. Unless one were to fly at speeds far greater than normal, there is no way the wing of an aircraft can produce enough lift to bend or break any of its structure. As long as you don't fly unusually fast, even very strong turbulence will not damage an aircraft. The wings just can't produce enough lifting force to bend anything. The airplane is not going to lose control. Airplanes have a built-in stability. They will not tip over. This means they will seek a natural state of straight and level flight. If you point the nose of an airplane up or down and let go of the controls, it will work its way back to level flight. This same leveling occurs when banking or turning an airplane. That's why planes can fly hands-off, just like a car should track straight down the road. Have you had an alignment lately? Your plane is a mechanical marvel. Redundantly designed and incredibly reliable, jet airliners are not only designed to be safe, but to make money. They don't make money sitting on the ground. The many reliable and redundant systems are there not only for your safety, but for economics too. The plane's systems are built to last. If a plane is repair-prone, the airline will find another plane to buy. Boeing and the other aircraft manufacturers know this. Jet engines are simple and reliable. Turbine engines are not complicated. There are no moving parts in different directions like on a piston engine. Jet engines just have a series of spinning fans. Air goes in the front and is compressed by fans, fuel is introduced and burned, and the high-pressure exhaust gases spin more fans to create thrust. It's called suck, compress, burn, and blow. There is no need for camshafts, timing belts, connecting rods, complicated valve trains, or ignition systems, except for the igniters which are used for starting. Once the fuel starts burning, it keeps burning. Just keep adding fuel and the engine keeps running. Really very simple and dependable. Jet engines are extremely reliable. Back in the days of piston-powered airliners, an engine might fail on average once every 4,000 hours of operation. This was considered fairly reliable, but when jet engines were introduced, the reliability increased tenfold. The odds are that I would have to fly about 3 careers or 75 years before I would experience an engine failure myself. And in the extremely rare chance of an engine failure, there is no phase of flight at which this should cause a significant problem. Every single flight is planned in such a way that if an engine was to fail, the plane must still have enough performance to fly safely. We are well trained to handle engine failures in every phase of flight. How the plane's pressurization system works. The engines draw in fresh, clean air which is compressed into the turbines. That air is fed into the air conditioning systems to cool it or warm it as necessary. This conditioned air enters into the cabin through the vents located near every seat. At the back of the plane is an outflow valve which regulates and restricts how fast the air escapes the cabin. The entire pressurization system is automated and monitored in the cockpit. If the automated system fails, pilots have control of the outflow valves by manual backups. As compared to other enclosed spaces occupied by many people, a jetliner's cabin environment is far superior. The air conditioning systems in most large buildings provide only 20% fresh air and are rarely equipped with high-efficiency filters like those found in jet airliners. They keep going and going. Quite often, after boarding a plane and reviewing the maintenance log, I note that nothing has broken on that plane for days or weeks, and when it does, it is usually something like a loose armrest or a tray table in need of an adjustment. Jet airliners are extremely well maintained. The FAA mandates that every airline comply with a very strict and comprehensive maintenance schedule. With all this maintenance and inspecting, there is still more inspecting. Before the first flight of the day, one of the pilots will do a thorough pre-flight inspection inside and out. And before flying each leg, the plane receives another walk-around inspection by a pilot. On top of that, every day when an aircraft flies to an airline's maintenance base, a mechanic will meet the flight and do a quick checkup on the plane and examine its maintenance logs. Most of the maintenance is performed by the mechanics and occurs at night during the plane's downtime. When there is major maintenance or a scheduled inspection to be done, the plane is taken out of service. As you can see, these planes are pretty well attended to. Failure of a system or component is rare, and when they do fail, there are many backup systems. As an example, the plane I fly, a DC-9 Super 80, has 3 main and separate electrical systems. It even has an onboard generating system. The plane only needs one electrical system to power everything. Even if all 3 systems failed, the plane's batteries would power many of the systems for a long time. And you know what? Even without any electricity, the plane still has a window, wings, and engines. It will still fly. It would be back to the basics, but really not a big problem. What makes a plane fly? Basically, wings and some speed through the air is all that is required to make a plane fly. The plane is just moving through the air, a fluid. The movement of a plane is kind of like swimming or surfing. Like water, air is a fluid. Air is just a little thinner than water, but it is still a significant mass. In fact, at this moment you are experiencing about 15 psi, pounds per square inch, of pressure from our atmosphere. You don't notice it because it has always been there, and it acts on your body equally from all angles. Speaking of how strong air can be, have you ever considered what holds your car up off the road? It's not really the tires, it's air pressure, about 32 psi. Think about it. Many people have a hard time believing that something as big as a jet can stay up in the air. What's holding it up there? Have you ever stuck your hand out of a car window at 30 miles per hour, then again at 60 miles per hour? Now multiply the force your hand feels at 60 miles per hour times 10. Actually, the force increases with the square of the velocity, so it would be even greater. That is the force your hand would feel flying at the speed of a jetliner. And if your hand was efficiently shaped like a wing, you could almost fly with just your 2 hands. The faster you go, the thicker the air feels. To the plane, it feels like a very thick, watery fluid capable of substantial support. Jet airliners look massive, but for their size they are very lightweight. For the most part, they are hollow and constructed primarily of aluminum. You have held an empty soda can, haven't you? It's very lightweight for its size. You take wings that big and get them going fast, and it creates a tremendous lifting force. Big or small, all aircraft fly using the same principles. No magic, just physics. Wing flaps. What are flaps, and how do they work? Flaps are used to create more lift so the planes can take off and land at slower speeds. The slower speeds make takeoffs and landings safer because the plane will not require as much runway. The shape of the wing has a small curvature which helps create lift. The greater the curvature, the greater the lift, but with a greater curvature comes greater drag. During high-speed cruise, it is preferable to have a flat wing to reduce drag. During takeoff and landing, the wing needs more curvature to create greater lift because the plane is flying slower. To satisfy both high-speed and slow-speed requirements for flight, wing flaps are used. Engines create thrust. A number of people think the engines keep the plane in the air. The engines don't make lift. The engines simply provide the push to keep the plane moving forward. And without the engine's push, a plane can glide very well by pointing the nose slightly downward, about 3 degrees. This provides the necessary speed. In fact, I'll let you in on a little secret. Jetliners glide on just about every flight, and they glide very well. Normally, about 100 miles from the destination airport, the pilots will bring back the engines throttled to idle. The engines are no longer providing the push. They are nice and quiet, and this saves fuel. Near the runway, the pilots will bring the throttles back up just a little bit in case any other maneuvering or speed changes are necessary. But the plane could land just fine gliding all the way to touchdown. So when you wonder what is holding the plane up in the air, imagine the air has turned into a thick fluid and the plane is simply swimming through it. How does an airplane turn? Easy. When flying level, the plane's lift is directed straight upwards. To turn, we bank slightly by moving the wing's control flaps, or ailerons. This redirects some of the wing's lift in the direction we wish to turn. Because of the centrifugal force of the turn, we don't feel any sensation of tilting. It's like riding a bicycle which leans into the direction of the turn. The plane's built-in stability requires us to actually hold the plane in the bank to turn. Some people may worry the plane will tip over in a turn. This simply cannot happen unless the pilot decides it's time for an air show and rolls the airplane over manually. Not a likely scenario. How does an airplane climb or descend? Even easier. To climb or descend, we move the plane's tail fins, or elevators, to point the nose of the plane slightly up or down. Then to keep the speed that we desire, we either increase or decrease the engine's throttle position. There's really no mystery about flying. You can think of it like swimming through the water. We have wings that provide lift, engines to push us along, and control fins to guide us. Whenever you are outside, take a look up at the sky. Notice how the planes and birds fly. Think about how they fly. See how they swim through the air. Try to get a little more comfortable with the idea of flight. The ATC system. Even though the sky is a big area, how do we keep planes away from each other? That's where the air traffic control system comes in. The controllers monitor radar screens in the tower and at ATC center facilities to ensure each plane is properly separated from the others. The controller is backed up by a computer which automatically squawks at the controller if proper separation is not maintained. The controller hates it when this happens because it means he has to fill out reports and answer to a supervisor. The separation requirements are fairly significant. Another fairly recent addition to our planes is an onboard collision avoidance computer. This system not only keeps us separated from other planes, but also warns us of terrain conflicts. The other high-tech backup is the good old windshield. At least one pilot's responsibility is to maintain a traffic watch outside. Next we will take a look at how weather affects flying. Fog. Fog is a very common occurrence and can be responsible for numerous delays. There are regulations which prohibit takeoff if we don't have a certain amount of visibility. If we don't have the required visibility, normally about 600 feet, we wait around until it gets better. Similarly, when a plane is coming in for a landing, the pilots must have a minimum visibility before we can even begin the approach. If the fog is really thick, most planes can be set up for an automatic landing. The aircraft autopilot can bring the plane right down to the runway, flare, touch down, retard the throttles, track down the centerline, and even apply the brakes. All the while, the pilots have their hands on the controls to back up the autopilot system, which has at least one other autopilot as a backup. The autopilot does a fairly smooth job of landing the plane, but of course not as smooth as my landings. If it is too foggy to land, sometimes we go into holding patterns to wait for it to improve, or we head to a nearby airport to wait. We always carry additional fuel and plan for landings at alternate airports whenever there is a chance for the weather to be bad. No matter how dreary it looks on the ground, it is always sunny above the clouds. Flying through the clouds is kind of cool. Layered horizontal stratus clouds are very smooth to fly through. Often you will not even feel any bumps at all. When flying through billowy cumulus clouds, you normally feel a bump or two when entering or exiting the cloud. Cumulus clouds often have updrafts, and the plane will go up a little when flying through these puffy clouds. Another reason the airplane might experience a little turbulence when going through clouds is due to changes in air density. Clouds are a little colder than the surrounding air, so the air density is slightly different. Snow. Cold weather can bring snow and ice. Flying in snow is no big deal, but it can reduce visibility similar to fog. We are also limited to how much snow can be on the runway for takeoffs and landings. Sometimes flights are delayed while airports remove snow from the runway. During snowy landings, we use our anti-skid brakes, wing speed brakes, and reverse thrust. But if the runway is reported to be too slippery, the airport will close the runway and we will land at a nearby airport. Ice. When ice is present on an aircraft sitting on the ground, we always call out the de-icing truck to spray special de-icing fluid onto the aircraft to remove and prevent ice. Once airborne, all modern jet aircraft have anti-icing systems to protect the windshield and wings, tail, engines, and other surfaces from the accumulation of ice. These anti-icing systems may use electrical heaters or hot jet engine bleed air to keep the ice off the aircraft. Thunderstorms. The one type of weather that we take very seriously is thunderstorms. Fortunately, there have been many advances in the detection and avoidance of severe weather. We have both airborne and ground-based radar as well as sophisticated satellite imagery to help us in planning our course around the bad weather. Recently, Air traffic controllers have been supplied with improved weather radar. This can be very helpful in directing aircraft away from the storms. Lightning. Lightning is associated with thunderstorms. However, it is not seriously dangerous to aircraft. I know it sounds frightening, but if an aircraft is hit by lightning, and my plane was once hit, it causes no harm to the aircraft or passengers. I have seen the effects of lightning strikes on a few aircraft, and all it amounts to is a small pitted area in the metal about the size of a dime. Aircraft are designed in such a way that every metallic part is wired together to allow the flow of electricity to exit through static discharge wicks located on the wings and tail. If you are flying at night through the clouds in an area of a thunderstorm, you may, on occasion, see flashes of lightning that appear to be very close. I have often noticed that flashes of lightning from over 50 miles away are visually transmitted through the clouds, and they seem like the lightning is very close. Remember, this is an illusion, and you are most likely a good distance from the storm. Wind shear. Wind shear can be a serious byproduct of thunderstorms. It is a sudden change in direction and velocity of the wind. Years ago, there were a number of incidents involving wind shear. Since then, a great deal of study into wind shear detection and avoidance has been accomplished by the industry. A new type of Doppler radar has been installed in aircraft and at many airports around the country to provide an early detection of wind shear. Also, a rigorous training program for the pilots is now implemented. It involves simulated encounters with wind shear and teaches pilots how to achieve maximum performance from the aircraft to escape the event. With the new technology and training, the effects of wind shear can be avoided and reduced. Rain. Strong turbulence is normally associated with a heavy rain of severe thunderstorms. Radar uses raindrops to reflect its beams. Radar screens display precipitation, not clouds. Standard industry policy is to give thunderstorms a wide berth of at least 20 miles. If a thunderstorm is near the airport, takeoffs and landings are postponed until the thunderstorm dissipates or moves away. Typically, thunderstorms travel over the ground from 15 to 25 miles per hour. So many times, if you just wait 30 minutes to an hour, the storm will leave and it will be safe to resume operations. Turbulence. Wind flowing over obstacles such as mountains can also cause turbulence. It is kind of like water flowing in a river with small eddies. A common wintertime turbulence occurrence is called mountain wave. This is produced downwind from a mountain range when the winter jet stream is at a lower altitude. The air mass in the mountain wave will flow up and down a little bit like sea swells. No, it doesn't make you seasick. This can cause turbulence and is typical east of the Rocky Mountains. Weather forecasters are very good at predicting this type of turbulence because it is easy to track the location of the jet stream. Often we change the cruising altitude of our flights to minimize its annoying effects. Turbulence can be caused by shifting wind currents in the sky. When you transition from one wind current to another, such as crossing a warm or cold front, the air can get stirred up. Planes flying through these transition areas will normally experience some light turbulence. Again, it may be annoying, but not a problem. One of the more common types of turbulence is caused by convective heating. As the sun warms the ground, the hot air rises and makes the air a little bumpy. You may see evidence of this by small puffy-shaped clouds. This type of turbulence is normally limited to the lower altitudes. You may feel convective turbulence for a short while after takeoff or before landing on hot sunny afternoons. It poses no danger and is rarely classified as anything but light or mild turbulence. Birds such as hawks and eagles use this rising energy of hot air to soar above the fields. This way they avoid having to flap their wings while searching for prey. It's kind of a free ride for them. There are many sources of information about turbulence available to pilots. We get information from the Weather Service, our company dispatchers, ATC, aircraft in front of us, and our own observations of what the sky and cloud formations tell us.
Thank you so much for your fear of flying course. It helped me out a lot. I'm terribly afraid of flying, or should I say I was. And I have a trip planned in a week, and I'm sure I'll do much better with this information. My biggest fear was turbulence. This course helped me understand turbulence, which was the main problem. I didn't understand it. Thanks again.
People often misunderstand turbulence. When encountering turbulence, nervous passengers feel the plane is falling out of the sky. It is natural for them to only feel the down bumps, but for every down bump there is an up bump. The down bumps are just more easily noticed. Car versus airplane turbulence. Have you ever driven fast over a bump in the road which caused you to come up off your seat an inch or two? It feels fairly violent, and the jolt would certainly spill any drinks you were holding. How large of a bump does it take to do this? Maybe 1 or 2 foot bumps in the road? But it feels pretty bad. Airplane turbulence bad enough to spill drinks and cause you to come up off your seat is very rare. But even if you do experience it, remember that the plane is not falling hundreds of feet. It just hit a bump a couple feet high. The altimeters in the cockpit would barely register the bump, so try not to let your imagination get out of hand. The next time you are driving on a bumpy road, imagine you are a passenger on a plane experiencing bad turbulence. Now take a look at the road. How big are the bumps on the roadway to create the rough ride? The air is usually very smooth, but sometimes small ripples can make it feel like bad turbulence. Turbulence in the news. Contrary to news reports, planes don't plummet when they encounter turbulence. Turbulence can be annoying, but it won't make the wings break. In over 25 years of flying, I have never felt that I have been in turbulence bad enough to jeopardize aircraft structure or control. For the most part, turbulence is merely an annoyance. So do like the pilots do. Always keep your seatbelts fastened while seated. Injuries can result from unexpected turbulence if you don't keep your seatbelts fastened. Unfortunately, some flight attendants and passengers have been injured while standing during unexpected encounters with turbulence. It probably doesn't feel too good to have your head bang the ceiling of an airplane. In summary, we have learned that planes are well designed and built strong. They have built-in stability and fly smoothly and safely, and they are thoroughly tested, inspected, and maintained. We have seen how simple flight is. Just keep your speed and you will have lift and control. The air mass in our atmosphere is very capable of supporting jet aircraft. We now know there are many procedures and backups in the ATC system to provide safe aircraft separation. We have learned the causes and effects of turbulence. While it may be annoying, it is somewhat common to experience a little turbulence on a typical flight. You must understand that turbulence will not harm the aircraft and it will not make you crash. Remember, before the flight, you can ask the pilots about expected turbulence. And finally, we are aware of modern advances in weather information technologies that make avoiding weather a breeze. With this lesson, you should feel more educated and comfortable about flight.